solving systems of linear inequalities. So our objective is to solve systems of linear inequalities. Who uses this? Explorers can use systems of inequalities to determine the rates at which they must travel to avoid bad weather. So let's start by graphing systems of inequalities. We had graphed in a previous section one equation at a time. You are going to do the same thing as you were before, only graph both inequalities on the same coordinate plane. So we're going to start at 4, and we're going to go down 2 over 1, down 2 over 1, or we could go up 2 and to the left 1. As long as your slope stays negative, we're doing all right. And then you can draw your line. Now, because it's an equals to 1, it's going to be a solid line. So we have ourselves a solid line, and now we need to decide whether we're going to shade above or below. I like to use my y-intercept as my means of figuring out whether to shade above or below, or you can always plot the point 0, 0. If you come out with a true statement, shade the side that uses 0, 0. If it is not a true statement when you're done plugging in 0, 0, shade the other side. So in this case, y is less than, so we want to shade below our y-intercept here. And I'm going to expand the highlighter. So we're going to shade down here. Alright, good enough. Okay, so now we want to graph our other equation. So I'll go green for this one. And when we shade, or when we plot it, we're going to plot it just the same way we did, only this time our line is going to be a dashed line because there's no equals to. So we're going to start at -3, and we're going to rise and run 1 because our slope is 1 over 1. You could also go down 1 to the left 1, and then draw your line. We now have a dashed line that represents y is greater than x minus 3, and now our last step is to shade. So y is greater, so we're going to shade above. So we're going to shade above. And your solution set, or your solutions, are the areas that are shaded twice. So the areas you shaded in red, and then the area you shaded in green. So the overlapping shaded region are all your solutions that will fit for both of these inequalities. Let's try this next one. Alright, so let's start by graphing our first one. We'll go in red again here. So we're going to start at 2. And this time we're going to rise 3 and run 2. Or we can go down 3 and go to the left 2. And it's going to be a solid line. So we have our solid line. And now we need to decide whether we're going to shade above or below. Well, since y is greater, we're going to shade above. So let's do this next one in green. So this one doesn't have a y equals 2. It's an x is less than 3. Well, how would you graph x equals 3? All of your x values would be on 3. So, well, that's the same idea here, only because there's not an equals to, we want to make sure it's a dashed line. So we're going to draw a dashed vertical line at 3. So now that we have our dashed vertical line at 3, we need to decide whether we're shading to the left or to the right, since there's not really a top or a bottom. So if all the x values must be less than 3, where are the x values less? To the left. So we're going to shade to the left. And same as before, your double shaded region holds all your solutions. Let's look at an expedition application. A polar expedition is 240 miles away from base camp, and the snowstorm is predicted to reach the area in about 48 hours. The expedition will travel as far as possible by boat and then walk the remaining distance to camp before the storm hits. The explorers can navigate the boat through the ice at a rate of 12 miles per hour or walk with the equipment at a rate of 3 miles per hour. Write and graph a system of inequalities that can be used to determine how long the explorers may travel by foot or by boat to reach base camp before the storm hits. So let's start by writing two inequalities. So your first inequality is going to be, we can use x and y. So your first inequality is going to be that it doesn't matter whether you're on the boat or you're walking. You have to do it in less than or equal to 48 hours. So together, you have to make it there before 48 hours hits. And now we place in the rest of it. So you can walk 3 miles per hour, and you can travel by boat at 12 miles an hour. And your distance is going to be greater than or equal to 240 miles. And now we graph. So you can graph this in two different manners. You can either get y by itself and start at your y-intercept and rise and run your slope, or you can utilize x and y-intercepts. So for example, your x-intercept and your y-intercept for this one would be 48. So we can plot a point at 48 or thereabouts on the top and the bottom, and then you're going to have a solid line going between them, and you would shade below. So let's start with that. So there's your first inequality, and now let's graph our second inequality. So when we find our y and our x-intercept, the y-intercept is going to be at 20, because 240 divided by 12 is going to be 20. And then your x-intercept is going to be at 80. It's 24 divided by 3 is 8. Add on the 0. So now you can plot each of those points. If you're having difficulty because it goes off the grid, you can always go and revert back to your rise over run. So here comes your line. And now we are left with shading. So our y value is going to be greater than or equal to, so we're going to shade above. So now that we have our double shaded region, we can, for example, the explorers can walk for 10 hours if they're on the boat for 25. Alright, let's look at a geometry application. So graph the system of inequalities and then classify the figure that you created by the shaded region, or the solution region. So take a moment and graph each of these equations. Well, when you return to the video, you will see a graph for each one of these. Alright, so each one of these lines, or inequalities, is graphed, but we need to actually complete the shading part. So when I end up having lots of lines that need to have shading either to the left or the right or the top or the bottom, I generally will write in a little arrow to show which way I need to shade. That way I don't have so many colors over the top of each other. I can't really tell which area had 4 colors versus 3 colors. So if we notice, we have to shade below the green but above the blue. So we need to be between these two parallel lines. And then we need to be to the right of the pink but to the left of the brown. So the area that we need to shade is going to end up being in this region right here. So your shaded region. Now, what shape does that make? Well, in this case, it makes a parallelogram. So, a parallelogram. And that ends our lesson on solving systems of linear inequalities.